Welcome everybody to the Git Basics workshop. Today we're going to be talking about a couple of different things. Yesterday we talked about GitHub, and we talked about putting together and thinking about how to run projects in GitHub. GitHub is in the cloud. GitHub gives you a lot of things, but GitHub is designed to work with something that's local. GitHub is designed to work with Git. And which raises the question, why Git? What is it good for? So first, we're going to talk about why you would even want to do something like Git. What's it good for? Then we're going to be talking about a Git and GitHub overview. How do these two things tie together? How do you use them? Then we're going to be talking a little bit about Git GUIs and maybe talking about hands-on command line Git. Maybe. If we don't get to that, then we will actually touch on that tomorrow. But we will get to it. We'll be talking about the commands today. The idea today is to get you very comfortable with the concepts of what's going on with Git and GitHub. And so then it doesn't matter. Once you're comfortable with the concepts, it doesn't matter where you're working, whether you're working in something which is a GUI, which stands for graphical user interface, point and click, or whether you're down at that command line and typing commands, you'll be very comfortable either way. So let's go and get started. I'm going to start with the sort of a Git and GitHub overview, but I'd like to start with some horror stories. So, and I'd like to hear some horror stories from you. It's always fun to hear about disasters, isn't it? So could you think about a time when you had written something, and this could be code, it could be a story, it could be anything. You've done some work, and then you did some other work, and it overwrote what you did before, and you couldn't get it back. So you overwrote what you did before, and then it was just like you couldn't remember what it was, and you couldn't get it back. Yes, Elijah.
Yeah, so this reminds me, there was a time I took a programming class, and there was a browser-based kind of place that I could code where I would eventually submit my code, and I was also writing code locally. And kind of in parallel with that, I had compiled this big, like effectively note sheet, but it was in code, and it documented basically a lot of the like functionality that I was going to be using. So I was referring to it frequently. And so I was copying back and forth between my local code for the project and the browser-based code for the project. And I realized at some point in time that in all of my frantic copying and pasting, I had selected all of my note sheet code and replaced it with my project code, but I'd done that about an hour ago. So no amount of Command Z was going to bring it all back. So I lost all of my notes.
Oh no. Wow. Well, that's pretty painful. That's a pretty good horror story. Oh, Lakea. I'm doing that wrong, but Lakea?
And a good participant in this. I think the worst case scenario, I think that's one good story. I think I might have been when I did my classes, but I think the worst case scenario for me would be virtually having my laptop, for instance. This is where I would do all my schoolwork. And at times throughout my time at Western Wahoo, somehow, some way, my computer would be corrupted when I did some of my coding, particularly for like when I did Java in a way. And somehow, some way, not only would I lose all that information I did and the notes, but it would take time for me to replace the hard drive with a new one. That's like the worst case scenario for me.
Absolutely. No, that's right. So that's an instance where you'd really want to have like kind of a backup, right, of the work that you've done. I don't know about you, but backups are really hard to do. I mean, I've been doing IT jobs, related jobs for like all my adult life, and I still have trouble doing my own backups. It's just hard.
I think one thing is this is a Apple, so would be for Time Machine in a way, but I know Windows would have like some kind of backup in their own cloud particularly. And then there's and then of course, I don't know, there's Linux, of course, which I have to get back into using eventually as well, because I know I gotta learn how to put backups on that kind of system as well.
Excellent. Great points. And we're going to be talking about something today, which is a little bit more fine grained too. So Amaya, did you have a story too?
I did.
Okay, please.
So, my only experience with coding was following a YouTube tutorial on making a 2D platforming like little video game where I would like draw pixel sprites and then this tutorial would let me like put code to them to make them move and stuff.
Yes.
And over a 3-day weekend, I had like a whole little game fleshed out. And then I just kind of like hit a wall with it. And I came back months later and I had forgotten everything the tutorial told me. So when I tried to work on it more, I just ruined it. And I didn't remember enough to fix what I ruined. So now it's gone. I can't even show anyone to it or show it to anyone.
Absolutely. Same thing, not sprites, but the same thing has happened to me. Absolutely great story. I mean, terrible story, but a very illustrative story. Others, ooh, Dr. Bell, Shara, I know you have one. Would you mind sharing yours?
I think it seems like I never learned to just keep using Git, but I had one where we were working on a project together, and I just when I was going through school, and we were working on a project together, and I thought that I was making some great decisions in deleting this chunk of code. And it worked, I ran it and it worked. And I was like, oh my gosh, this is perfect. But it turns out in the chunk of code that I had deleted, it was kind of the update line for the entire GUI that we were working on. And so everyone else was like, why is this not updating anymore? And then I just got this like scathing email from the professor that was like, don't make these sort of changes in the future. And I was just really just discouraged. But if we would have been on a very robust type of versioning system, then we might have just been able to, revert the changes that I had made and go back to the, previous version.
Yes. So these all point up to a really kind of a common problem, which is, you lose what you've done. Mafe, did you have another story?
Oh yeah, actually it was recently, not that recently, but last year, by the end of last year, my computer decided to stop working out of the blue, and I didn't have a backup for probably 3 months, and I haven't pushed things into GitHub for another month, and I had like the last version of my manuscript there, so it was very I was very scared. It was horrible, but luckily my computer fixed and I was able to retrieve everything. So since then, I've been pushing things and doing backups every week.
Right. So here's a funny thing about backups. These are great stories. Thank you all so much. Backups are a little bit brute force, right? That's kind of like you can, Apple calls one of their services time machine, because you can go back to time. But that means you have to lose everything that came after. And it's also for the entire file. It's for the entire hard disk. It's really pretty big. So it's not really fine grained. So it'll solve some problems, like if your hard drive dies, but it won't solve problems such as you made a change to code that you really wish you had not made. So still some problems. So how are some ways that you sort of try to save versions of something that you've written? What are some ways that you do that? Anybody save multiple files? Yes, Adrian.
I was thinking if you wanted to modify the code, but if you wanted to keep the original, I guess you could create another variable that is essentially the same as the code that you just did, but then you'd make changes to that variable you just made, so that way you keep the original data, whatever.
So you could do it sort of in code. You might also do something like where you comment code and then you have the new code underneath. I certainly have done that. Anybody rename their files? Yeah, give me a thumbs up if you ever renamed files.
Or you could give your another file a different name that's the same and then make changes to that one.
Mm-hmm. A lot of people rename files. This is one of my favorite XKCD cartoons. XKCD is all about these graduate students, you know, so final ... I am done. Okay, yeah, professor marked it up. Okay, final 2. Final review comments, until it's finally just this long name. So how many people have done something similar to this? I certainly have. Yeah.
Yeah, I pretty much did that. Yeah, I pretty much kind of had that kind of situation too. Not as much, not kind of like that cartoon, but there's been a time that I had to like change some of my files too as well.
Absolutely. And again, it doesn't really solve the problem though, is if you change a little part. So let me ask you, let's think through this then. Think of all the problems that we sort of touched on yesterday and we touched on today. So we have we have problems now of trying to keep track of what we've done, keeping fine-grained track of what we've done, being able to roll back and get back to the previous things that we've had. Yesterday, we talked about sort of keeping track of everything that everyone's supposed to be doing. That also raises the problem of how you can work together in the same file. So Sharo's story, for example, was exactly about that. There were multiple people working in this file all together, this important file. And just by one person making a mistake, it was not your fault, Sharo, it was not your fault. Then it just could, you know, ruin it for everybody because one person made a change. So these are all problems that we have. They may seem sort of unrelated, but it turns out they're actually related. So let's think about these problems and why we want to use Git and GitHub. We want to use Git because it gives us a really fine-grained and excellent way to do versioning. We want to use Git because it allows us to unwind changes without just replacing the entire file. We want to use Git because it allows us to track what the changes were and what their intent was. Sometimes the problem is you don't know where you made the change or why you made the change. This especially comes about if you come back to a project a little bit later. And I don't know about you all, but when I started my graduate career and was doing a lot of programming, I would do an experiment and then you'd write the paper and then you get the comments back and then reviewer number 2 would say, well, why don't you run this other experiment? And then I'd have to go and recode that data, recode that experiment. I have to go back and say, why did I do that? And I'd say, that's stupid what I did. I'm going to redo it this way. And then I go through and realize, oh, because the Apple operating system doesn't allow this. So I had to go back and change it again to my workaround. So what I really needed to know was, why did I make that change when I made that change? So Git allows you to track changes and their intent. It also, with GitHub, allows you to share those changes with others and give that visibility to others so you can say, here are the changes I've made and here's why I've made them. It allows you to save that work in a safe space. So it's not saving everything on your hard disk. You have other pictures on your hard disk, you're still going to lose it. But you know that code that took you 10 hours to write, that's going to be saved. And saved in a way where you can easily get back to it and restart your work. It allows you to combine changes with changes made by others. Because you have this fine-grained versioning that works to fold in your changes, but it also allows me to really nicely put in changes that other people have made as well. So Jessica and I are working on a project, let's say. She makes some code changes. I'm able to put those in and to sort of fold those into my code in a way that's respectful to both of our work and allows us to make informed decisions about what gets included when. And as we saw, GitHub, in addition to all of this, between Git and GitHub, GitHub gives you that GitHub project so you can track the work that needs to be done. You can estimate the amount of work that's remaining on a project, and you can test out additions before they're included in projects. So let's take a look at where these different capabilities come from. So these top ones, this is Git. And this is actually a function of local Git. Now we get into the more social aspects of it. And this is GitHub, often abbreviated GitHub, GH. This is where GitHub comes in. And GitHub works really closely with Git. Combining changes with changes made by others. Okay, this one right here is a part of Git, but it's a way of using Git that's called GitHub, that's a G, really, GitHub Flow. And that's a way to use GitHub and Git together, to actually work together to make sure that you can combine changes. And all of this is something that we saw yesterday, which was GitHub project. Okay, but all of this is just Git and GitHub. So what we're going to be talking about today, what we're going to be concentrating on today is this part right here. So we're going to be talking about Git, versioning, unwinding changes, and tracking changes and their content. Before we dive into that, are there any questions about this and about what we talked about yesterday? All right. Then let's start by talking about something that does versioning that we are all familiar with. How many people here have used Google Docs? So give me a thumbs up, or yeah, or a virtual thumbs up if you've used. Yeah, tons of people. You know, we almost all have used it, right? And you know that one thing that you can do here, if you need to, is you can, let's say that you're, you did this, and this could be something like, let's say somebody added that to the document. You can say, whoa, 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 no. And you can roll back. You can change your version and go back to a previous version before they put their stuff in. But it's all sequential. So it's all versioned, and it's a snapshot, and there's no way, you have to go, this is kind of like time machine. You need to go back in time to a particular place, but you can. It may not be a capability that you've used, but actually it's there, and you can go back in time a little bit to an earlier version. It's a very handy thing to do. There are some things, though, that you can't do. So, for example, you can't do this thing where two different people are working on the same thing. What's happening is they work interactively in the same document at the same time. We've seen that, right? Where you have like anonymous pigeon, an anonymous aardvark, when we're all editing that file together. But what you can't do is go to two different ones, have clean sort of versions that you experiment with, and then pull them back together. That'd be a really nice thing to be able to do, because what you'd like to do is to say, well, this is how, this is how, Dylan was thinking about it, and this is how I was thinking about it. Now let's go ahead and make some decisions about how we're going to pull these together. So I'm going to sort of edit this a little bit. I'm going to change mine a little bit, and then we're going to make the final document. It doesn't work like that. It'd be nice to be able to do that. That's not how it works right now. So the other thing that you can't do is you can't get all these documents, all this work being done by whoever's doing them. You can't go and say, gosh, you know what? I really love part of this document, but I want to just I want to keep the I want to get rid of the work that came before. I love this part, right? So I love this part. This is a great addition, but I don't love this part. In Google Docs, what I'd have to do is I'd have to go all the way back here, and I lose everything. But actually what we can do with Git is we can be very selective. We can say, oh, I want to include that change, but not that change. Now put the document back together for me so I have the selected ones that I have. So a couple of really nice capabilities. So in addition to being very granular and selective and saying, ooh, I want to keep these changes, but not these changes, and being able to sort of create two different clean versions that we both kind of work on and then decide how to put together later. In addition to that, you can also comment about how to, about why you made those changes. So here you could actually have a little message. You could say, you know, why you made that change. This is what Git is all about. This is what Git does for you. And what we're going to be learning today is how that works and how to think about what Git does. So when you start a project, where do you put your stuff? What's the kind of the first thing that you do when you start a project? Oh, yeah, not a bad idea. Making a list, absolutely. So yeah, so you add and you name it. What are you naming? Yeah, often you make a folder, right? Because you have to have a place to put all this stuff. So one of the first things that you do is you make a folder and you start putting stuff into it. Absolutely. Matt, maybe put it into categories. Absolutely. But you have to have a place to put your stuff. So that's where we're going to start with a GitHub. And a GitHub repository really starts with the idea of you have a workspace. And a workspace is just a subdirectory. So think of this green space here as this is your subdirectory, your folder, you know, same thing. But that is where your work is going to go. Everything that happens to a repository happens within this workspace. So the repository actually exists in that subdirectory. It's actually a file in that subdirectory. So what the repository is going to be doing is it's going to be keeping track of the changes that you make. Now, it's not going to keep track of everything you do. What the repository is going to do is it's going to allow you to tell it what you want to track, which files you want to track, and when you're ready to sort of record the changes that you've made. And it will allow you to put a message in there to say why you made that particular change. And the repository is actually creating a snapshot of the files that you indicate at that particular moment. At some point, it does a compression, but it also creates what's called a hash. It takes a fingerprint of the chain of the files as they exist at that time and stores it away. But you have to tell it which files you want to track and when you're ready to record those changes. Why do you suppose it does that? What would be a reason why you would tell it which files you wanted it to track? Why not track everything? When you are writing, let's say you're writing code, is your code instantly running and instantly in sort of the shape that you'd like to hit save? Are you hitting save like continuously, save, like every character? No, right. So even though it's local, you are taking a snapshot. So you'd kind of like to take a snapshot when you're ready. Okay. Now, what about, and so you got to tell it when files are ready to be taken a snapshot of. It's like, are you ready at all times to have your picture taken? No. You're like, give me a minute. Give me just a quick minute. Okay, I'm ready for my picture now. Same thing with your files. You want to be ready when that snapshot is taken of your files. So the way that we say that something is ready to have its snapshot taken is we add it to a staging area. A staging area is not necessarily a place, really. A staging area is more of a state. It says, here's a list of the files that are ready to be put into the repository. I'm just going to say, hey, I'm adding it to the staging area. This file is ready. This file is ready. This file is ready. The actual act of adding it to the repository is called the commit. So adding a file to the repository is a two-step process. One, you add it, you say it's going to be ready. And the next time that you're ready to make the commit and put it onto the repository, then you make the commit. The other thing that the commit message allows you to do is with a -in parameter, it allows you to add a comment. So this can be any sort of a statement. The best kind of a statement is one where you, in your mind, you say, with this commit, So if I'm writing, for example, I'm writing a description in a file, and I add information about the project, and really it's all the background that someone would need. Then I could say, with this commit, that's the change that I've made. So with this commit, intro project. Now this commit is actually going to be stored in this repository. This change is going to be stored in the repository as a snapshot, and it's going to have this message attached to it as well. And it's also going to have a unique identifier. Remember that I mentioned that when you put things into the repository, it takes a fingerprint, it takes a thumbprint of all the files that are being put in there at that time. It's called a hash, and it gives this long alphanumeric label, unique label to what's going into the repository. So that's called that's going to be the name of your commit. So that's the pattern. You do some work in the workspace in your files. You save that work locally, right? Then you say, oh, I'm pretty happy with how things are going to be going. So here you're in the workspace. You've been doing some work. When you are working on a file in memory, is it on the disk yet? See, let's say you add a line of text. You haven't hit save yet. Is it on the hard disk yet? When does it appear on the hard disk? What do you have to do to get it to the hard disk? Yeah, you have to save. Exactly. That's right. So you have to save it before it's available. So you save it, then it's in your workspace. Then when you're happy about it, then you can add it. Then when you're ready to actually make a commit, when you're sort of done with this little block of work, you can do a commit, and then it appears in the repository. And then you continue your work. These are actually the commands that you use. So at the command line, you would say, you've got to tell it that you're talking about Git. So you'll say Git add, for example, and you'll say Git commit. But those are the commands that you use. These are the verbs, though. Chetan.
Yeah, I had a quick question. So if you are saving in a workspace, why do you need to sort of go through the process and save in your repository?
Yeah.
Is that's like more of a block, or?
Yeah, so let's say that you're just saving to your directory, right? And you go back and you tear out a whole bunch of other stuff. You know, it's late at night, you've been writing something, you're unhappy with it, so you delete a whole bunch of stuff and you write some new stuff. Then you finally get a good night's rest. You wake up in the morning, have your cup of coffee, you look at what you've done, you say, oh my gosh, what have I done? I want to go back. Too bad. You saved it. It's overwritten, you know? However, if you saved it, if you had previously saved it before you got irritable at night and changed everything, if you saved it before then, you said, okay, this is in a decent shape, I'm just going to go ahead and add it. Now I'm going to make a commit. And then later on that night, when you were grumpy, you changed everything, and the next morning you go back and say, oh my gosh, this is terrible. No problem. Now you can roll back because it's stored in the repository. So this, remember what it gets us that ability to roll back. So already we have that ability to do versioning We have the ability to unwind changes. We haven't talked about how to do that yet, but we have the ability to unwind changes. Does that make sense? Excellent. All right. Now, let's think a little bit more broadly. Is there anything here that we've talked about so far that's going to save us if our hard disk crashes? Anything that's going to save us? Let me ask it this way. Are we still in trouble if we drop our laptop? Yeah. Yeah, we have no outside backup, do we? We're not there yet. So yeah, we are still in trouble if we drop our laptop. Absolutely. But you remember we talked about this GitHub thing, right? So it turns out that all that GitHub really is doing is it's taking your repository and it is copying that repository to someplace on the web. So it's taking that repository and making what's called a remote. The remote repository is just someplace which is safe, which is out here. And even if you lost everything, you could ask for that remote to come back. And it's kind of cool when you get a copy of the repository and you want to recreate everything, you just replay it. It's like you're replaying all the changes that you made before until you're back to where you were before. A little bit different from a backup. It's not an image of everything all as it currently stands. It's a recording of everything you've done that you've added and committed up to that point. So you have the remote repository, and that is on GitHub. So this is on the web. This is your computer. So the command that we use to push that stuff up, what would be a good command? What would be a good thing to call that command where you're taking a repository and you're pushing your command, you're pushing your repository up to the remote, up to the web? Yeah, why not call it push? That's what you're doing. Matter of fact, that's exactly what it's called. It's called push. So push takes all your changes, moves them up there. And keep in mind that really what's happening here is the repository is communicating with that remote. So those are the only ones talking. It's not directly your workspace. It's not that staging area. It is the repository communicating with this remote. Okay, what do you suppose we might want to call it when we ask for those changes to come back? Let's say somebody else has been working on the remote and we want to get their changes. What do you, if we push it up there, what do you suppose we call it to get it back? Absolutely, pull. Fantastic. Now remember, actually what's happening is the repositories are talking to each other. So at this point, when you do a pull, first what happens is that it syncs this repository with this repository. Then in the background, what it's doing is it's saying, okay, it's made these changes. I understand that really what you want to have is for those changes now to appear in your workshop, in your workspace. So sort of behind the scenes a little bit, it will go ahead and instantiate those changes. So it found some changes up in the remote. It put the two in sync. Now you have your local repository. And it says, oh, and I know you want me to update your files. I'm going to update your files. So it updates your workspace. So that is how that works. And now it becomes a cycle. So on a fairly regular basis, what you want to do is you want to do some work on your workspace. When you're at a place where you have a nice quanta of work, and you shouldn't wait too long for this, but quanta of work where it's kind of like, okay, the files are kind of in the shape that I like. So this might be a couple of times a day. It might be at the end of the day. That's kind of long. It could be at the end of the day. You do your add, you say, okay, this file is ready as it is. Okay, then you can make your commit, add your message to it. This is, with this commit, I did these different things. And then just open the repository. And then And then a little bit less frequently, maybe, but you don't want to wait too long. You'll say, okay, now I'm ready for that remote repository to be in sync with my local repository. So any changes I made here locally, make them remote. Now this becomes available to everyone, right? That you've shared your GitHub repository with. Now they can see your work. Now they can see your changes. From their end, they can say, ooh, new work. I'm going to do a poll. And then they get the copy of the work that you're ready to share out. Let's say they do the same thing. Now they do a push. Well, now you're ready to do a poll and you're ready to be in sync. So you can think this is not something you want to do like monthly, right? Because can you imagine trying to include all the changes since somebody made monthly? No, you want to be on a regular cadence. And there are a ton of different ways of doing this. That's what we're going to be talking about tomorrow, is one particular way that we think is a good way for analytics. So what questions do you have about everything up to this point?
In the remote repository, so are you like getting a list of the like all the changes that have happened? Like that seems like a lot to go through.
Yeah, you are actually. There's I'm glossing over a few things. There are some ways that you can the way I'm describing is everything going to main. It turns out there's actually something we're going to touch on the very end here, which is you can do branches. You can work on branches. So you can do your experimentation until you're totally ready. And then you can bring all your changes in with what's called a merge. But generally, yeah, you actually, if you're all working on the same project, you all want to eventually be in sync with everything. Keep in mind, behind the scenes, there is compression that's happening at different places at different times. When you get other people's work, there are ways for you to sort of decide what you want to keep and what you don't. So you can all sort of agree on what needs to go into that main code work. But generally, yeah, you do want to see everybody's work, right? You do want to see all the changes that everybody's making, because in the end, it's going to be a single project. Does that answer your question? Okay. So there was a question about, yes, so we're going to actually practice using GitHub in these workshops, especially tomorrow. We're going to see if we can get to it today, but I like to make sure that we get to the topic first to get to it conceptually. Mateo, you had a question about the purpose of the index. So the index, that staging area, is meant to keep the track of which files are ready to be committed. Because you might have scratch files, you might have data files that you don't want to put into the repository because it's huge. There just maybe private stuff in that subdirectory that you don't want to have included. So that staging area says, the next time I make a commit, only include these files. These files are ready. These are the only ones that I want to have go in there. Technically, you could, in the commit, say, commit this file, this file, this file, this file. But that's really clunky. Turns out it's really handy to be able to say, oh, add this one, add this one, add this one. Now commit everything that's in the list. How does this integrate into an IDE? Great question. So I keep on talking about all these commands. This is what happens either because you give the command or because you're in a GUI, a graphical user interface. But this is all that's happening at that point. Again, we'll see if we can get to it today, but otherwise we'll get to it tomorrow. You're going to be seeing a GUI and you're going to see the command line. But no, in the back end, even if it's hidden from you, all that's happening is exactly this. So even though it may be hidden, there exists a staging area. There exists a repository. You are doing commits. You are doing pushes and pulls. The nice thing is that the GUIs tend to call these what they are. So even if I give you a brand new GUI, a brand new graphical user interface, which entirely hides all these commands, now you know what to look for. I want to take my work, I want to move it up to the remote repository. I'm going to look for something that says push. And you should be able to find it. So once you understand this level, then you can work pretty much anywhere. You just have to keep these concepts in mind. Yes, that's right. Thank you. And a small break, absolutely. And this is recorded so you can get caught up with that. Oh, and do not worry about being called on. That is great, Miranda. Thank you. And let me go ahead and ask, do we want to take give me a thumbs up if we want to take a quick 5-minute break right here in the middle. Give me a thumbs up if you'd like to have a quick 5-minute break. Okay, let's go take a 5-minute break. And when we come back, I'm going to talk a little bit about how to actually use this stuff for projects. All right. So let's do 12:20. We're going to come back in 12:20 in 8 minutes. Okay. 12:20. Perfect. And I'll pause recording. Preston, if you can remind me. So I had a question. Will we learn how to actually implement and practice in Git and GitHub besides learning these theories? Yes, as a matter of fact. What I found is that by understanding what's happening, you'll actually understand the later implementations much, much better. One complaint that people have about Git and GitHub, and Git in particular, is, my God, it is so complicated. You know, there's so much going on. And it's true, there's a ton going on. And, you know, frankly, you know, Git was created by, you know, a bunch of hardcore programmers who were building Linux, and it looks like it. But the fact is, it was built to solve problems. So you have to understand the problems that it's being built to solve and how to do those main things first and keep the high level view. Then even if you get down into the nitty gritty, you'll be able to navigate much better. So the practical application actually begins right now. So we were talking before about how we're working locally, and then we are, so here we're local, right? And here we have this on the web, and we're sharing here. And we have this nice cycle going, right? You know, where you might have changes that are here, and they get moved over here, and then you do work, and then you're going to add it, and then you do a commit, and then at some point you may decide to push. So this big circle, it's like a train, merry-go-round. My question for you is, when do you get on the merry-go-round? What comes first? So if I were to tell you that, in my opinion, it's a bit of a pain to first create the local and then have it create the remote, where do you think you might want to get on the train if that's true? Where it's kind of a pain to start here, then where would you start?
Did you say my name earlier?
Nope.
Okay, I thought I heard Amaya. Sorry.
Oh, no, that's fine. Where do you get on the merry-go-round if it's not local? Oops. Boy, and I've just, okay, good. Mess that up, there we go. Yeah, I always vote for the easiest path. I don't describe myself this way because it's you know, it's not very professional, but I consider myself lazy, but in a good way. I don't like to waste effort. And I like to make things as foolproof and as simple as possible. So I'll tell you what I do. I start with the remote. Efficient, that's a much nicer way of putting that. Work smarter than not harder? Absolutely, I'm all for this. So what I tend to do is I start, oh, I love that. Productive laziness, fantastic. So I start with the remote. Think about everything that's in the remote, and it's a GitHub repo. Think about all the things we saw yesterday. There's the README, there's the issues. It's actually a really good place to start. Someone comes to you and says, I have a project. Maybe the first thing that you ought to do, instead of taking notes on a piece of paper, or instead of creating a subdirectory on your computer, maybe create a repo. Create it right away. Let's go ahead, let's take a look and see what that looks like, as a matter of fact. So let's see if I can, I'm going to stop that screen share, and I'm going to go to, yeah. So I'm going to go to this one. But let me go ahead and I'm going to start. I started a test repo, but I'm going to create just a brand new one. So what does it mean for you to start with a remote? Well, that just means that you go to your handy GitHub. I have a GitHub organization that I've created. So I'm going to GitHub organization, but you can go to GitHub as well. Sign in, and there's a friendly green button. I love the GitHub friendly green button. That is usually the next thing to do. So I'm going to click new. Then here I can actually name it. So in this case, let's say that I'm going to be building a new chatbot. I'm going to create a teen chatbot that chats like it's a teenager. So my project is going to be called Teen Chat Bot. You can absolutely do this, by the way. As a matter of fact, Tamara has had to leave, but we're building an application actually that is meant for teenagers, and this is going to be one of the things we need to do. Chatbot trained on teen/youth vocab and speech. Okay. Here, although I currently can't spell, well, I knew that. And I can make it private or I can make it public. Here's the key. You always want to say, add a README. And here's another key. I mentioned this before. You always want to choose a license. I'm going to choose the MIT license. We're not going to talk about that here, but there's really good information here. You always want to add the README. You can make it private or public, but add the README, and then you create repository. So now what you can do is you can go ahead and see the little pencil icon right here. You can just start editing this file right away, taking down important notes. And there's really good lessons online about how you do the formatting and things here, but the fact is you can immediately begin your work. Notice what it's saying here. It's not saying save. It says commit. When you edit stuff here on the repository, up here remotely in the repository, it's a little bit different. You're interacting directly with the repository. It's kind of weird. You're working directly with the repository. And that's why you're not saving or staging or anything. It's like, are you ready to commit your stuff to the repository? Now you'll notice it's saying right here, commit directly to the main branch. I'll make this a little bit bigger. We're going to be talking branches a little bit later. But I'm going to go ahead and remember it has the, this is your space for your message. Remember with the commit, why did you make the change? Does anybody remember the phrase that we use in order to help me phrase to write down what a good commit message would be? Because I got to tell my future self or tell my collaborators why I wrote what I wrote, why I did what I did. People have been in the workshop before. What's the phrase? This is a tough one because I only said it once. Yes, that's it. Adam, Amy, Andrew, you got it. With this commit, what am I doing here? With this commit, I create an example. Why do you suppose I don't need to write with this commit? I added taking down important notes. Why isn't that my message? Yes. Okay, go ahead.
So I believe that the taking down important notes is, well, you just put that down because it's pretty much your details. This is your commit change is basically the title of what you're expected to do, right? For this program.
So this is already, remember in the commit, it's already taking a snapshot of what I did. So The repository itself has the recording of what I did. Now, what we want to do is we want to write down why I did it. With this commit, I did this thing. So that's why the commit message is, you don't have to describe exactly what you did. That's already recorded. People can look at it and see exactly what you did. You'll get a really good sense of that tomorrow. And then I'm gonna commit my change. Okay, let's go back and let's take a sort of a look at the top level of this again. So look at this. So now it has the change that I have here, and look what it has right here. Create an example. So I can click on this and it can show me exactly what I did. So this is what's happening in the repository. And it can show me what the difference was from the previous one. Here's a really long number. What do you suppose that really long number is? Yeah, it's the ID, it's the hash, it's both. It's the name, it's the hash, it's the ID for the commit, all of that. So what it did was it took a thumbprint, took a fingerprint of the whole file that I was changing. I was only doing one, just the README. This was the almost certainly unique number that identifies that particular change. The chance that two different commits would have exactly the same fingerprint is vanishingly small. So I can use this to refer to that commit, and it uniquely identifies. As a matter of fact, the repository is just a collection of these commits, the files that are associated with them, and pointers to where everyone is. I may be working back here, you may be working up here. And tomorrow we're going to be talking about branches and how those work with those as well. Okay, great. So this is all well and good. I'm working remotely. I have my repository. Do I have anything local yet? I don't, do I? I just have everything up on the web. So I want to make it local. I want to take steps to make it local. Where on the screen do you think I should click to take my next step? Yeah, it's always the big green button. It almost always is a good choice, the big green button. So here it says code, clone. So it turns out that's the command that will move things from the remote to local. So I'm going to come back to this, and then we're going to show you the actual commands that we're going to generate to do this, and then I will and then I'll show you actually how to do this. Let me go ahead and share this again. All right, give me one quick moment. Okay, I'm going to end my share. Well, yes. Okay. So we've started with the remote. Then what we want to do is we want to break it local. So we actually want to move this repository. So what's going to happen when I want to move this entire thing, I want to create a copy down here. And that's called clone. And you remember that's what's happening is the repository talks to another repository. So it's making a copy of itself locally wherever you told it that you wanted it to be. And then behind the scenes, it's going to go ahead and create your workspace. And now you're on the merry-go-round. Now you can go ahead and make changes here, add, do commits. Whenever you're ready, you can do a push. Whenever you want to see the changes that have happened, you do a pull. So all of those things can happen now. So let's go ahead and take a look at what the actual commands are. I'm going to just flip forward to that real quickly. So you can sort of see what the commands look like. We'll come back to all this. So it's git clone, and then it has this long thing right here. So the git clone command requires the location of where that remote was. That's what you need to have that clone command. So let's go ahead and take a look at what that looks like and how you do that from the remote repository. How do you get that information from the remote repository? Remember before, we're up here, we're remote, we want to make it local, we want to be able to do this clone thing. Click on code, it's clone. Here's the location of the remote repository that we want to make local. We want to clone and make local. What's interesting to me is it's actually just a file. The file is called .git. The .git file is the heart of the repository. That's the list of all the commits. It's the list of all the commit messages. It's a snapshot of all the files at the various stages. That's what you actually need. So what you need to do is you say copy, and that copies this for you. And then you want to go local. I'm going to show you actually what this looks like locally. You'll have an opportunity to do this. We will take this up tomorrow for you to actually do it interactively. I'm going to ask you to install a few things before tomorrow. But I'm going to show you what it looks like right now when I run this locally. So let me share my screen. Let's see here. Okay. You're going to be installing something which is going to give you the ability to do what I am doing right now. Go ahead, move this around. To be a little bit different between Windows and Mac, but we'll go through those differences. So I'm going to go to Documents. I'm going to go in. I always create something that's called Projects. Then what I'm going to do is I've installed Git locally, and we'll have instructions for you later on tonight on how to install Git. What that's going to allow me to do is to do something that's called Git bash. So I'm doing command line, but we'll also see how to do this with a GUI as well. But so I'm just browsing to where my documents are. I'm going to projects. I'm going to say, I want to do Git bash here. You can't do this until you've installed Git, but that's fine. We'll be getting to that. You're going to watch first. Okay, so now this puts me in command line. So remember that the cheat sheet said that we needed, anybody remember exactly what that command that I'm supposed to type is? What's that command called? Git clone, yeah. Git clone, git clone. So the command is clone, but I've got to tell it that it's git. So I say git clone, almost everything starts with git something. So git clone, and then I've got to paste in what I copied from up here. So when I went up here, I said I copied that location. It's the full location of that. So it's I'm gonna paste it right here. So git clone this thing. Watch what happens. Oh, and I hope this was a brand new computer and I forgot to put my credentials in here. Uh-oh. I should have tried this out first. It might throw in.
It's very likely that you have a tab right now.
Yeah.
With GitHub asking, you can X that out and then type in your username and it'll hide your password automatically. So if you alt tab right now and open up, you should find, or
yeah,
there should be one from GitHub.
Yeah, and this is my problem from having too many things open. So funny. Okay. I might have to do this in just a moment because I do not see where my.
Oh.
Oh, wait, no, nope, that's not it.
Yeah, I've been there, done that. In
Yep,
terms of, I know we've been there, done that.
yep, exactly. So that is, yeah, thank you, Noah. So this is buried someplace, and I'm gonna have to come back to this in a moment. What should be happening if I don't mess this up? So I did git clone, so what's gonna be the next thing that's gonna happen or supposed to happen? What's gonna be the next thing that's gonna happen? So it's remote. So what is it going to do? Yes, it's going to download the repository into some directory. Absolutely. So what's happening is what we asked it to do was this. We asked it to clone. So now it's going to move that, it's going to create this workspace for us. It's going to move the repository in there. It's going to replay everything that's happened in that repository, which consists of the initial commits, which was the creation. And then it's going to recreate my one edit, and it's going to be local. And then I'll be able to do all of the cycles right here. And then as we say, I'm on the merry-go-round. So a couple of things. The authentication for Git and GitHub has just changed in the last few months. It is much easier now, but it does this thing where it asks you to authenticate on some system window. And when you have too many windows open, it can be a little bit tough to find that system window. The nice thing is, the first time that you do it, you're set forevermore. It so happens that this is a brand new computer, like brand new. I got it yesterday. So that's why it's not already registered to be authenticated. Okay. Let me go ahead and let's review a little bit, and then let's dive into the commands a little bit more. Give me a quick moment.
And Jesse, if you like, I can demonstrate some of the commands. If you just want.
If you could do that, that'd be perfect, and then I'll get ready for the second part. Thank you. Here, and I'll stop my screen sharing so you can take it over.
Okie doke. So let me see. I may have spoken too soon because I do not have a repo created, but I mean, you can.
Oh, go and create one.
Okay,
Go through the steps again. I think that'd be very useful.
I shall. Okay. All right. Here we go. Let me create a new window because I too have many windows open. All right. Let's see here. Let me go ahead and share my screen. All right. So here we are at Google. We're just going to pop on over to GitHub. For me, it always, oh, let me make this a little bigger. I don't know why I always have this super small because the fact is I also can't see it. So
Oops. Oh.
Sorry. Okay, let's see. And, oh, this is, sorry, I might actually be the source of the background noise.
No, that was my mistake. Again, I'm just here to help.
So actually, I think I'm going to clone this one. I'm going to share with Jesse, and I'm going to clone this one. So here, as you see, we're going to grab this this green button, as Jesse said, big green button. It makes you just want to press it. So you just press it. Then I just pop into whatever. Let's see, right quick. Where is my, okay, get a directory here. Let's just grab this one. Oop, oop. And here we have my documents. As Jesse said, we tend to like to sit in projects. So I'm going to go ahead and put that one down. So if you have installed this on Windows and you've done it with Git Bash, that has like a contextual pop-up menu, so you can just right click and then do Git Bash here. Also, if you are on OS X, this will just be your regular terminal. Often you have the same types of capabilities, but you might have to add them through a command line. Okay, so I'm going to try this through Git Bash. I haven't used Git Bash in a long time. I might have to switch over to the Anaconda prompt, but let's try this now. So as Jesse was saying, we type git clone. And here, I believe this is going to be a shift insert to paste. So there now that we have the repo that we're trying to clone, we can just try to do that. Now also, sometimes when you get stuck here, it also can be that sometimes GitHub is a little bit slow itself. So sometimes it takes just a second for it to, connect. So here you can see that we've cloned here. And we have cloned this team chatbot. Let's see, is it there? Oh my goodness, here is the repo. So let me take a look. Going into there, will I be able to see this README? No, it doesn't want to preview it. But we would be able to see. I'm going to Notepad++ it right quick if I can. Let's see. You can see that I actually have exactly what Jesse wrote. So now I can collaborate. If I'm added, which I think I am, I can collaborate with Jesse on this README. So I see someone is asking a little bit about Git Bash. If you're on Windows, you will have to use Git Bash unless you have Anaconda installed, at which point you could also use an Anaconda prompt. So if you have an Anaconda prompt, what I usually do to access that is I just click there and I just start typing it in. So Anaconda, and then this will pop up. So you can use this in the exact same way. This one is, if you're on Windows, it's going to be a PowerShell. So you'll have just a little bit, okay, so you're on a Mac. You do not need Git Bash at all because the terminal is so amazing that it's like already there for you. So what you may, if you don't have already the terminal kind of in your, I forget what this thing is called, but it looks like this. I don't know if you can see that at the bottom, but it's like a black screen. And so that black screen, you'll be able to do, it is a bash terminal. So you will be able to do these exact commands without installing Git Bash.
Yep. And Aaron just mentioned that he was able to go to the regular command prompt. So long as you've actually downloaded Git, and we're going to do that in just a moment for people who are on Windows, just to make it simple, so you can you'll be able to be ready for tomorrow. Once you do that, then yeah, you can get to it in lots of different ways.
And shall I show something else?
Yeah. So if you can, yeah. So I would say if you could show a few of the commands and just sort of, that would be wonderful.
Okay, that sounds great. So let's see. Maybe would you prefer that I created a new file or amended a file?
Oh, dealer's choice.
Okay, so I'm going to actually amend this README. Let me open it again. So here I'm going to edit with Notepad++. And again, if I was using Jupyter Lab or Jupyter Notebooks, I would be able to just kind of do that directly. But since I don't have that open, we'll just do it here. I could also do it through like a Nano or an Atom or something like that. But instead, we'll just do it like this. Okay, so let's see, maybe team chatbot, maybe I want to say, our meeting dates. We will meet every Wednesday at 4 p.m. to discuss updates and plan future meetings. Okay, that sounds good. So now I need to, okay, so where am I now? I haven't saved. So have I updated my workspace or have where am I right now? Where do you guys think that I am? Or what do I need to do next to update my workspace? Oh, beautiful. Save precisely. So I'm just going to Control S it, and Notepad++ kindly just changes that to show that I've saved it. Okay, wonderful. All right, so now that that's saved, I'm actually just going to ease that on out the way. Now I can come back to my Git bash. So here is a pitfall of pitfalls. So when I'm in my Git bash, you see that I just cloned this, right? So I cloned this repo, but I'm actually still in projects. So I actually need to go in the repo so that I can do the commands that I want. So let's see, we're going to CD right on into, what is this called? Teen Chatbot. So something awesome about a lot of these terminals, if you just kind of start the name of the directory, you can just press tab kind of in the middle and it'll complete it for you. So now we're going to CD, and CD stands for change directory. So we're changing directory into Teen Chatbot. All right, and you can see that now we're in here. Got some little words here. What is that just popped up? So this can kind of make you feel comfortable that you may be in a Git repository. This is actually the name of a branch. So now we can feel comfortable that we're in a repository. Otherwise, how in the world would we do the Git commands without a repository, a Git repository? Okay. All right. So let's see. Maybe I left my computer and I came back. I don't actually know where the repository, like the state of the repository. Do you guys have any ideas about what command that I can use to figure out the status of my Git repository? Git status. So git status is literally just one of my favorite commands. One, because I forget where I am every 25 seconds. And so I need to remember what I have done. And also because git status will tell you a lot of things about, give you recommendations about what you might want to do next. Okay, so here we are. It says, look, you're on the branch called main. Looks like you're up to date with your local version of origin main. It looks like you haven't staged some changes for commits. Git add that file to update what will be committed. If you don't like that, you can discard the changes in the working directory using this command. Thank you. And it looks like it says you don't have any changes added to commit. So what do I need to do to add things to commit? And where am I adding them to specifically? Double question, super hard.
Yeah, I believe that you would probably, it depends on what file you want to go for. Are you trying to save this into your project file?
Yes, I am trying to update this in the repository because I want Jesse to know that we need to meet every Wednesday at 4 p.m. So right now I'm in my local repository and it's just kind of changed in the workspace. But how do I, someone said it. Oh my gosh, Aaron, very good. So I need to add the file because that will add it to then the staging area. And then the staging area, once I commit that information in the staging area is what will go into the repo. Okay. Ooh, Aaron, you're a good guesser then. All right, let's see. So let's see how that goes. We can git add, and it says we should add the file. The file that I've modified is here in red. It says readme.md. Thanks, Git. So read, Oh, it didn't want to it did. So I just typed read and then tab, and it filled that in. So I'm adding this specific file to the staging area. So I'm just going to press enter. Let's see what it does. Okay, not much. So now I have forgotten where I am again in my life. So I'm going to git status. Let's see what it says. It says a little something different now, right? It says, look, you have some changes to be committed, which are these, because you've added this to the repository. Now you can commit that. But if you don't want to commit it, you can also just revert it back to what it was. So unstage it. And you can do that by using git reset head and then the name of the file to unstage it. All right, so now it's on the staging area. And I think Aaron said that we can go ahead and commit that. Yeah, we can go ahead and commit that. Okay, so we commit that. What's that command that we used to commit again? Oh, it looks like Aaron Yes, so someone has just brought up a really great point about Git restore. So depending on the version of Git that you have, sometimes it will make different recommendations about the specific commands that are available, but it always makes good recommendations, mostly. Okay, so let's see, we're going to commit. Aaron told me that I should type git commit. Okay, is there anything else that I should put here? How will I tell Jesse what I've done in this commit? So I want to, oh, good. So I'm going to type -m, and that's just a flag to tell git commit that what's coming after this -m is about to be a message. What would be a good commit message? In this commit, and you can either unmute or just drop something in the chat, which I could use as my message. In this commit, oh my gosh, brilliant. Added meeting instructions. I love that. Added meeting instructions. Okay. All right, that looks good. I'm gonna press enter there. Ooh, it says some things back to us. It says, look, you were on main, and here is something that we talked about, the commit hash. And it said that is the title of that commit hash, and that's the things that you've done. And it's like, look, you have made these changes, and we've made those changes for you. Thank you, Git. All right, so then let's see. I wish I could make this a little bit bigger. It just drives down. Okay, so now I say to myself, okay, well, now Jesse knows exactly what's going on. Let me go back to the repo and see those changes. All right, so, oh, I don't see my line here. Maybe it's not here. Let me refresh. Oh man, it's still not here. What has happened? What do I need to do to get this up here? How can I tell Git to push this up to the remote repo? Oh, thank you, Sunny. That is a great idea. Git push. Let me give that a try. So let's see right quick. Obviously, again, I've forgotten where I was, so I'm going to git status it. Let's see what it says. Oh, curious. It says now that my branch, so where I am on my local computer, is ahead of where it was by one commit. Why is that? Because we just made that one commit. Great. And what does it say? Use git push to publish your local commits. I think I will follow that advice and Sunny's advice. Okay, so I'm going to do git push. And whenever you guys get on to talking about pull requests and branches, there are a few more commands that can come to the end of this about which will specify the branch. But at this point, I'm just going to do git push because this is already tracking. And so that statement made absolutely no sense. But when you learn more about git branches, it will. Okay, so we're just going to git push. Let's see what it has to say. Probably going to say something. Anything. Oh, it looks like it's saying something. Looks like something happened there. We can see that it looks like it said something, but whatever happened, it looks like it pushed it up to the repo, so the remote, and it pushed it up to main, so the branch that I was on. Okay, so now I come back here. Oh my gosh, things haven't changed. Maybe I should refresh once more. Oh my goodness, and there are our changes. So now you've actually been through a complete cycle of how you can clone your repo from a remote. So we were on GitHub and Jesse made this, and then I was able to clone it to my computer. I made some changes to the README using whatever editor I wanted or whatever IDE was necessary. Then I saved that to make sure my workspace was updated. Then I added those changes to the repo using git add. I committed those, I added those changes to the staging area using git add, and then I committed those changes to the repository, the local repository, using git commit, and I gave a really nice message here about that I added some meeting instructions. Thank you for the person who suggested that, Aaron. And then after we had that locally, we noticed that it wasn't on the remote branch, so we realized, okay, we have to push that up to the remote repository, and we did that using git push. So that is the full cycle of how you can start on GitHub, make a repo, clone it, make changes, and then push your changes back. Thank you, Jesse, for allowing me to do that.
Oh, thank you. So you've been through the full cycle now. It seems like an awful lot of work to just sort of, when we could have just used Google Docs, except that this scales up to however complex your project is going to be. You can have multiple people pushing code. You have a reasonable, a really good pattern that we'll talk about tomorrow about how to decide what changes get adopted and which ones don't. So now you've accomplished almost everything that that we wanted to accomplish with the pain points that we've had that we mentioned previously. Tomorrow, you're going to have the opportunity to actually try this out. Keep in mind that this command line is kind of like the most complex way to do it. It's the most powerful way, but it's the most complex way to do it. And yet it's actually not even all that bad, because with get status, it actually tells you what you probably want to do next. So you type get status, it says, hey, it looks like it's this. Here's the next step you probably should take. On the GitHub repo, there's a big green button. So you always have clues about what's going to be coming next. So tomorrow we're going to be doing this by, you're going to have a chance to do this on your own. You're going to see what a GUI looks like as well. And you're going to realize it's the same game. It is clone, it is add, it is commit, it is push, it is pull. Always the same thing. Just one you type out, one you click and point. Now, how do you put all these together? We're going to be talking about that tomorrow, but how you put this together so you can actually work together closely as a team. We'll have instruction posted a little bit later on today to make all of these installations just so you're sort of ready to go, and you can do this on your own. We'll do some breakout rooms tomorrow to practice all this. Thank you all very much. We'll see you tomorrow.
I know, but the things